This is part 2 of our video on solving trig equations with factoring. So this equation here says 2 cosine cubed x plus 10 sine squared x minus cos x minus 5 equals 0. And I would like to try to solve to figure out what value of x I could put in this that would make this whole thing equal 0. So first thing I notice when I am looking at this equation is that I have 2 cosine terms, 1 sine term, and a number. So ideally, I would like them to all be cosine or all sine, or at least have sine or cosine as part of each term. So I would like to see if maybe I can use an identity here in order to replace something to either make it all cosine or sine. Now I do have 2 cosines, which makes me think maybe I could find a way to take out sine squared x and put in something that uses cosine. And my personal favorite identity is what we are going to use. So my favorite identity is the one that says sine squared x plus cos squared x equals 1. Now you can take this identity and rearrange. So I do have a sine squared x that I'm looking to get rid of. So I would like to know what that is equal to. So I would subtract cosine squared x from the other side to get sine squared x equals 1 minus cos squared x. And then what I'm going to do is take out sine squared x and put in 1 minus cos squared x. So this is going to become 2 cosine cubed x plus 10 times 1 minus cosine squared x. We're taking out the sine squared, putting in 1 minus cosine squared. And then that is still minus cos x minus 5. I did not give myself enough room, equals 0. Sorry about that. For my next line, I am going to multiply 10 into the bracket. So I would get 2 times cosine cubed x, and then 10 times 1 is 10. 10 times negative cosine squared x is negative 10 cosine squared x minus cos x minus 5 equals 0. Just going to box that off so that I know it's not part of what I'm trying to write right now. All right, I would then look at whether or not I have any like terms that we can collect. I only have 1 cosine cubed, so that's my 2 cos cubed x. I only have 1 term with cosine squared, that is minus 10 cos squared x. I only have 1 term with cosine x, that is minus cos x. But I have 2 terms that are numbers. I have the plus 10 and the minus 5. 10 take away 5 is 5. So this is plus 5, and then that equals 0. So now all of it is written in terms of cosine, except for the 5. So I feel like I have a better chance of being able to factor. Now, when I'm solving by factoring, I do always want one side to equal 0, so I'm happy with that. And then I'm going to try to see if I can factor this. Now you have a choice. If you want to use variable replacement to take out the cosine, you are welcome to do that. If you would like to leave the cosine in and factor, then you're welcome to do that as well. Whatever makes the most sense to you is what you should do. So I think I'm going to do variable replacement. I'm going to take out cosine of x and let that be some other letter. I always choose a, so I'm going to pick a. I'm going to let a equal cosine x. Not cosine squared x, not cosine cubed x, just cosine x. So that is going to give me 2a cubed minus 10a squared minus a plus 5 equals 0. Now this has 4 terms. So I need to try to think of how I'm going to factor something with 4 terms. So when I look at my sheet, the very first thing it suggests is a common factor. Do these have a common factor? Unfortunately, they do not. So then I would move down the list and I would try grouping. So it's always worth trying to group. If it works, great. If it doesn't, we erase and we go back and we try something else. So I am willing to try grouping to see if this works. First pair, both divide by 2 and a squared. And then 2a cubed divided by 2a squared is a. Negative 10a squared divided by 2a squared is minus 5. The second pair, negative a and plus 5, don't really have anything in common. So I'm going to take out a 1. And because there's a minus sign in front of that first number, I'm going to take out a minus 1. Negative a divided by negative 1 is positive 1a, or just positive a. Negative 5 divided by negative 1 is negative 5. That still equals 0. Okay, so from here, I do have the same bracket. So this is 2a, nope, just a, minus 5 times 2a squared minus 1. And still equals 0. Okay, from here, it is factored. Could I factor further? Well, a minus 5 does not factor further. 2a squared minus 1 has some of the markers of being a difference of squares. It has 2 terms. It is being subtracted. I have a squared. I have 1, which is always a perfect square. But I also have a 2, and 2 is not a perfect square. So I am not going to factor this as a difference of squares. So seeing as how it is factored, I am going to take each part and set it equal to 0. Now you could at this point put your cosine back in. I think I'm going to finish solving for a first, and then I will put the cosine in afterwards. So a minus 5, what makes that 0? That would be a equals positive 5 if I add 5 to both sides. And then I'm going to move this over a little to give myself some room. I have 2a squared minus 1 equals 0. I'm going to add 1 to both sides to get 2a squared equals 0 plus 1, which is 1. Then I'm going to divide by 2. So a squared equals 1 over 2, or 1/2. And then to eliminate a square, I would square root. So this is the square root of 1 over 2. And because it is an even numbered exponent, that means there are 2 possible answers here, one that is positive and one that is negative. So it is plus and minus the square root of 1 over 2. So I am going to look at 1 and 2. Can I take the square root of 1? Well, the square root of 1 is 1. So I'm going to write that as 1. The square root of 2 is a decimal, and we're not using our calculator, so I'm going to leave that as the square root of 2. And then last thing we're going to do is split this into 2 possible answers. We have a equals positive 1 over root 2, and a equals negative 1 over root 2. So now that I've solved for a, what I need to do is put back in the cosine. So a is really cosine x. So I would have cosine x equals 5. I have cosine x equals 1 over root 2. And I have cosine x equals negative 1 over root 2. Okay, I think I am going to stop this video here, and then we will start the next video from this point and continue on with our solution.